Alright, 7.6. Today is going to combine properties from our last section with a process that can be used to solve higher level problems, which is the variable is in the exponent. The higher level problems where the variables in the exponent. The last type of problem we saw was the following, where we had 125 equals 25 to the 2x plus 1. In this problem, I told you that you really can't get to the variable. There's nothing we know to get to that variable, so what we learned to do was to say, okay, how about we write this as 5 to the third and turn that to 5 squared, which turns out to 4x plus 2. And then once we had that, we were able to ignore the bases and focus just on the fact that 3 equaled 4x plus 2 and solve it. But the question arises, what do we do when the bases are not the same? What happens when 3 to the x equals 40 and this cannot be written as a base of 3 because there is no power of 3 that leads to 40, at least not one that we can find. And this is most important when the phrase powers and logarithms or inverses comes into play. If you want to remove the base, you must use a logarithm to do it. So consider the step of logging both sides is what I would say, is turn this into log of 3x. So put a log in front of this and put a log in front of that. Now we can use the expanding properties with the exponent. So again, based off of what we learned in our last section, because this is in the power, we can actually move that in front, which is what happens here. And then once we have x times log 3, we can move to log 3 by dividing by log 3 on both sides. And then from there, carefully type that into your calculator. I do say careful because a difficult part of programming logarithms into your calculator, I'm jumping here, is that the calculator is automatically at a parenthesis. So when you type this in, as soon as you hit, let's say I'm doing it on one where it doesn't have a fraction, and I hit log 40 divided by log of 3, you need to pay attention to your programming. I know you're not computer programmers, but math is computer programming, which is why I was so good in my programming classes, because of my math background and problem solving. This parentheses means I am doing the log of 40. This is actually a log of 40 divided by log 3 instead of log of 40, parentheses closed, divided by log of 3. And you really don't need to close it on the 3, but again, that is actually the log of 40 divided by the log of 3. And when I say every calculator does it, I have a series of calculators here just to show you that when I turn this on, if I can turn it on, I haven't used it forever, and I hit the log button, it gives you a parentheses. Again, most of them do. I have a TI 30X, which used to be the good one before the multi-view came out. When I hit the log button, it gives you a parentheses. The graphing calculators that you'll use at some point, when I hit the log button, where's log? Is it even there? There it is. But when I hit the log button, it opens up a calculator, or opens up a parentheses. So the key thing is make sure you understand how to type that in. Now the good news on this calculator is that when you do a fraction and you put log 40 over log 3, your calculator is smart enough to take these two things and separate them. Again, you could put your parentheses on the back of them, but because that's already in a fraction, your calculator is going to separate those numbers. But this is going to, I guess, 4 digits, so 3, 5, 7, 8. But that's it. So what we ended up doing was taking two numbers that we could not convert to the same base, putting a log in front of both sides, moving the power in front, and then solving by dividing. Again, to me, it's a very simple process, but it's something you need to make sure you practice in order to be good at. Again, if you were to do log 8 plus log 3, don't just do log 8 plus log 3, because that is actually taking the log of everything in here. That answer is different than this answer. And again, you don't need to close the second one, but you can see these two numbers are different because this is actually taking the logarithm of all this, whereas this is taking the log of 8 plus the log of 3. So when you type those in, please be careful. Write a note in your on the side of your notes there to say, to make sure you close your parentheses on logarithms, because from what you just saw, every regular calculator tends to put that parentheses on the back of your logs, or to start your log off, so make sure you're ready for that. So let's put a pin in that information for a moment while we just consider our ability to evaluate difficult logarithms, because I told you before that you'd be able to figure out difficult logarithms using your calculator, but it's now the time. So how do we get our calculator to evaluate the log base 2 of 8? Because remember that if we do log of 8, based off of what we know, that is log base 10, because remember that's a common log button. Whenever you hit the log, that's 10, so that's not actually going to give you the right answer. Based on our experience, we know that it should be 3, because it should be 2 to the x equals 8, and therefore x equals 3. But our calculator doesn't give us the answer of 3. It gives us 0 point something something something. So in order to do this, we need a process called the change of base formula. Essentially, it's easy to understand. Think of the word base. Knowing that a base is typically a foundation of some sort, where on a fraction would you expect to place a base? On the top or on the bottom? Well, hopefully you're thinking if it's a base that it would go on the bottom, because again, the base of something would typically hold everything up. It's kind of like the foundation. And if you know that, then you already know the change of base formula. So I say that in such an easy way, not to insult you, but to help you understand, not to overcomplicate things. That's where most people fall short in math. Don't overcomplicate it. If the base belongs on the bottom, then you know that the base should go to the bottom of the fraction. So looking at this, in order to apply the change of base formula, we simply use the common log button, which is your logs, but we put the base on the bottom and the other number on the top. And when we do that, again, remember that this should be the answer of 3. We do our fraction log 8 over log 2, and then everything works out. This even works with that ln, which is a different kind of logarithm, but again, you could even use ln for that, which we call natural log of 8 over natural log of 2 is still 3. So these two numbers, as long as you follow that rule, always will work to your advantage. But again, whenever you want to find the logarithm of something, or the value of a log, use the change of base formula, and that'll get everything you need. So again, this is where your homework is, the easy stuff, or should be the easy stuff once you practice it. Use the change of base formula around to the nearest thousandth. So log base 13 of 15 means put this number on top, because 13 should be on the bottom. So no, I don't want a fraction there. I'll just do it the real way. So log, no, I'm not going to. Fraction log 15 over log 13 equals thousandth. 1,000 has 3 zeros, so that means we want 3 digits. So 1, 2, 3, which would be 0, 5, 6. Solve, round to the nearest 10,000th. Well, 13 to the x squared equals 333, or 33.3. Here again is the problem that we had, where we had to rewrite them as bases. But here is where we can actually use our conversions. Again, remember I told you strategies that you need. In this one, it's best to convert it because we want the x to be alone. So what I would do is rewrite this as log base 13 of 33.3 equals x squared. I would then use my calculator. Actually, I guess I would. I don't know. I think I'd square root both sides, because if I want it to be as precise as possible, I'd want it not have to round. What I'm saying is, if I were to convert this first to be log 33.3 over log 13, if I round that one, I'm already losing precision. Again, every time you round, you're cutting off a billion numbers, which changes the actual final answer. So I'm not going to round yet. I'm actually going to just go ahead and do this part as square root of this equals x. That way I get the answer, because again, if you have a decent calculator, which I think even the one online is solid, you should be able to type in the square root of a fraction, which is log 33.3 over log 13. 10,000th. The number 10,000 has 4 zeros, so therefore we want 4 digits. 1691. Now let me just show you real fast what would have been the difference if I converted that first to be log base 13. Maybe it doesn't throw it off too far, but let's see. So let's say I converted this before square rooting. So I'm again going to go to 10,000, so that'll be 1667. So it would have been 1.3667 equals x squared if I did not square root first. And then when I go to square root these, I get the square root of 1.3667, which gives me, we just so happen to barely make it. But look at this number here. This does give me 1.1691, but this is our answer here. and this was our answer there. Notice that has a 6 turning into a 1, whereas the answer we have right here has a 5 turning into a 1. So notice how just that small adjustment throws off everything. So whenever you're rounding, especially if you're in like a science class or something like that, make sure you ask your teacher if you should round throughout the process or if you should leave everything in perfect form and round in the end. Again, this is the most precise mode, even though it's not precise because we rounded, because we only rounded once. Every time you round, it's like you lose integrity on the problem. So since we waited until the very end to round, this is more this has more integrity than this one, because here we rounded that and then we rounded the square root. So that would be 2 rounding processes here, 1 there. And kind of like whenever they talk about copies, how the copy of a copy is, you know, loses quality. Same thing. If you round like 5 or 6 times in one problem, you're really changing the value of that answer. Okay, so how do we solve this? 9 to the b minus 1 equals 7 to the b. Well, the only thing I know, and this is probably the toughest one that you're going to see, but 9 to the b minus 1 equals 7 to the b. Because I have to get rid of these bases, remember the bases are the opposite of log, so log of 9 to the b minus 1 equals log of 7 to the b, because that's the only way we know to crack into this thing. Again, we can't ignore these things, and we can't make the bases the same, so the only option we have, thinking strategies, is put a log in front of both of them. That means that the only strategy I know to do is to move the powers in front, so this becomes b minus 1 log 9 equals b log 7. Now I will tell you that you have to do it this way, so when you do that, you do not need to worry about spaces. You could actually type parentheses b minus 1 log 9 into your Math Excel, and it'll mark it right. So don't worry about where the spaces go. Just make sure you have your parentheses where they need to be and all that. But this problem is definitely one of your homework problems that you have to show work on, and that's only because I know that what's his name, Photomath, likes to just give the answer in a whole different way. So make sure you work on this if you want to get this right. Other than that, now that we have 2 things multiplied by log 9, logic says let's distribute the log 9 to both. So I get b log 9 minus, I guess, 1 log 9, which I'll just put it there, but you really wouldn't put the 1 there, equals b log 7. Now this is where experience comes in, because to me, I know where we're going, because again I can envision a little bit, and I know that I want to factor, and I know I want b to be alone. So this is where you might want to put a star and put an explanation. We want our b's to be on the same side, and again this is your full explanation. We want b's to be on the same side so we can factor it out. You'll see what I mean in just a second. So I'm going to move this over by subtracting it, getting negative 1 log 9 equals b log 7 minus b log 9. And again, this is where your experience comes in, because once you've done this, you don't need to think about why you're doing it anymore, because you know what's going to happen. Now I'm going to factor off a b, so negative 1 log 9 equals b times log 7 minus log 9. That is a good spot. And again, from here to here, that's a little wizardry, yes I know. But once you do it enough times, you'll understand if I have a b over here attached to something and a b over here attached to something, that I could actually move that over here and then factor off the b and get everything where I need to be, because now that b is multiplied by all this, our answer is 1 log 9, sorry, negative 1 log 9 over all of this, because we simply divided both sides by log 7 minus log 9. And there you go. And here's where your programming is important, because I have to put that on the bottom of a fraction. Need a fraction first, silly. Negative 1 log 9 over, again, I don't need to close it on top because that's the end of the expression on top, log 7 close minus log 9. So whenever you have that issue that you're not getting the same answer, if you're using a calculator like this, it's probably because you forgot to close it. But going to the nearest hundredth, again, 100 has 2 zeros, which means 8.74 is your value of b. All right. So again, the key part was from here to here. That is the part where you've never seen it before. You've kind of seen it before. You just never use it to your advantage. But that is something that once you learn that trick, you become a much better mathematician in terms of solving, because this does pop up a few times in your future in a process. The good news is you won't have to do it without being warned about it. But if a teacher warns you that you need to be able to get from here to here, and you're too stubborn to practice getting from here to here, then you might not belong in 6-weight. Solve, round to the nearest 10,000th. So this here again is the same thing. The only thing we want to do is make sure we understand how to do it with a less than symbol, because this thing is very delicate. So we need to make sure we do it the right way. Again, we can't write both of these as common bases, which is our first strategy. Since we can't do that, the only option we have is to put a log in front of both of those. The second thing we have to do now, because we're already in that train, is to put these powers in front. So P log 6 is less than 5 minus P log 13. With that, again, think about where we are, distribute, and like I said, hopefully as you practice, you can see what's going to happen. We're going to distribute this. I'm not even going to do it yet. I'll just talk about it. We're going to distribute this, getting 5 log 13 minus P log 13. We'll probably move the other P to this side, factor off the P, and then divide. So again, the more you do it, that's why you practice it, so you can actually see what's going to happen. Because when you've done something a million times, I won't say a million, but enough times, you know where it's going by the time you start to do it. Minus P log 13. And again, once we have a P over here and a P over there, we're going to move this over, making it positive. So log 6, which is P times log 6, plus P log 13 less than 5 log 13. Again, once we have those here, pull off the variable. And from there, move that over again, simply putting this on the bottom. Calculate this answer. Let's see, fraction 5 log 13. Again, don't need to close it on top because it's the last part of the expression. Log 6, definitely close it, plus log 13. Again, don't need to close it because it's the end of the expression. And it said 10,000th, which 10,000 has 4 zeros, so it'll be 1, 2, 3, 4, which means that'll be a 7, 9, 4, 3, 7. Now, did this even come into play? No, it didn't. The key thing is making sure that you understand that equalities, inequalities, less than, greater than, not equal to, greater than equal to, less than equal to, that really only comes into play, as I taught you earlier, when there's a negative value attached to x and you have to flip it, or whenever your x is over here and you need to bring it over. So again, the inequalities shouldn't bother you too much. Just make sure you are careful a little bit more than usual, because you don't want to make a silly mistake being careless in that case. I'll stress the importance of learning strategies. Each lesson that we have faced should have had another tool to your toolbox. The students who survive higher levels of math tend to do so because they have a better collection of tools. When I say that pre-calculus and calculus will weed those students out who have been using other forms of assistance at home, I'm not lying to you. I can't stop you from taking shortcuts, but I don't have to. As I said, there is no shortcut through pre-calculus, calculus, discrete mathematics, differential equations, all the things that get really, really crazy. And I'm not saying that to bother you. I'm just saying that the whole difference between students who survive it is competitive stamina. When all you do to solve a problem is take a picture on your phone or type it into some website that gives you the answer, you're getting the answer, but you're not getting any stronger. The students who are actually working through it, struggling, getting mad, dealing with the anger, coming back, doing it again, those students are building competitive stamina. Just a quick story, since I know we have time, since the other two videos were short, is as a coach, I realized that my students had an issue dealing with controversy in games. So what I did as a strategy is I made sure to put them through as much controversy in practice. Every single drill we did had a punishment included. Every single drill they did, if they did something wrong, they did push-ups or they ran or whatever, which put stress on it. And so they had very stressful practices, yes. But the thing was, once they got used to dealing with the stress, when they faced stress in games, they didn't crush or they didn't crumble because they got used to being under stress. So competitive stamina is important. Unless you're working through these things and struggling through them and emailing me and wanting to curse me out for giving you that problem and thinking you want to quit and then coming back and doing it again, every time you do that, it might take you 5 minutes before you get tired the first time. But then after a year, you might be at 10 minutes. And then after another year of working out hard problems, you might be at 30 minutes and then an hour. And again, you just got to think about it. That stamina is important because that is the difference. Students who are allowing themselves to struggle have the stamina to keep pushing through to get, when they get tough. So without that skill, as I'm saying, math will eventually put problems in front of you that you'll just say, I can't do it because it's taken more than 2 minutes to get my answer, because you've never experienced struggle. You've never experienced controversy. So again, for those of you who are struggling through and doing it the right way, keep it up because it will pay off. Now, I don't know how it's going to pay off. I can't say you're going to win $1 million, but I will say that because you're struggling through the work, because you're experiencing the pain of failing, because you're experiencing the pain of falling, you're also experiencing the confidence of knowing that you fell, but you got back up and you were able to do it. Whereas students who are not going through that process are not learning how strong they are, and so it's going to be tough for them later on. So please just do your best to accept the challenge now. Again, let me know where you need assistance, and good luck.